Okay, in this video, we're going to talk about parallel and perpendicular lines. Parallel lines look like this, and there's a few key things we need to know in parallel lines. First thing we need to know is that for parallel lines, they will never, ever meet. They will never touch, they will never cross, they'll never intersect, they're never going to meet. Okay, and the slopes of parallel lines are exactly the same. So if the slope of one line is positive 1/2, the slope of the other line must be positive 1/2. Parallel lines will also have different y-intercepts. And that's true because if you were to have a line that has the same slopes and the same y-intercepts, then it would just be one line. It would be the same exact line. So to have two lines, to have parallel lines, they have to have the same slopes and different y-intercepts. Okay, and this right here for us, writing equations of lines, is really key. Perpendicular lines look like this, and perpendicular lines form a 90-degree angle. That's what perpendicular means. So perpendicular lines form a 90-degree angle, also called a right angle. And then we have some very important information about the slopes of perpendicular lines. They have opposite, reciprocal slopes. And what that means is opposite means change the sign. So if we started with a positive slope, we now have a negative one, or if we started with negative, we now have a positive. And reciprocal means flip the fraction. Okay, that's very important. So another way, and I'm going to show you how to do this with equations of lines, but some way that we can check to make sure that lines are perpendicular is if the slopes multiply to equal -1, then we know that they are perpendicular. For example, if one slope, the slope of the first line, is 1/2, then the slope of the second line would have to be, we change the sign and we flip the fraction, so 2 or 2/1. This is going to be negative, this one's positive. If I multiply those two things together, they do equal -1. Okay, let's look at some examples. Write the equation of the line that passes through this point and is perpendicular to the line with equation y equals 2x minus 7. Okay, well in this equation, this is in the form y equals mx plus b form, slope-intercept form, so we should know that this is our slope. And if you don't know that and you need to go back and watch a different video, that's fine. But this is our slope. So the slope of our first line, we'll call it slope 1, is 2. That means in order for us to write an equation of a line that is perpendicular to that, the slope that we need is going to be the flipped version of that. So we can put a 1 under this. That doesn't change the value. We're going to need a 1/2. And since this one was positive, we need this one to be negative. So we're going to use this slope for our new line. And we're also going to use the point that we were given. Okay, and so all I need to do is write an equation of that. Now it doesn't tell me what form to write the equation in, so remember we're always going to start with point slope form, and if it asks for a different form, we can change it then. And there's a video on writing the equation of lines in different forms if you need to go back to that. So we're going to write y minus our -2, which is our y value, equals the slope that we chose for our perpendicular line, -1/2, x minus our x value. And the last thing I'm going to do is clean this up a little bit because we don't like double negatives. Double negatives here make a plus. So y plus 2 equals -1/2 x minus 3. And that is point slope form, and I'm going to stop there unless I'm told what form to write my equation in. Okay, let's look at another example. In this example, we want to write the equation of a line that passes through this point, and in this case is parallel to this line. Remember that parallel means they have the same slope. The problem that I see right now is that I can't look at this line the way it is and find the slope. So in order to do that, I do need to write this line in slope-intercept form, which basically means I need to solve for y. So I'm going to move my 3x over here. I get -5y equals -3x plus 12. Then I'm going to divide by -5. Divide every single term by -5. And so y equals, this double negative here is going to make a positive 3/5 x, and then this is going to be minus 12/5. But this is what I care about because this is my slope. This is the slope of my first line. And since I want to have a parallel line, I want it to have the same slope, my second slope is going to be exactly the same thing, 3/5. And then I'm going to use the point -5, -8, and I'm going to write the equation of the line. So y minus -8 equals 3/5 times x minus -5. And then I'm going to clean this up. Double negative makes a plus. I have 3/5 here. X, and this double negative is also going to make a plus. So this is my equation of my line of point slope form. Again, if you're not familiar with point slope form, go back to the equation, to the video on writing equations of lines, and I'll explain that further. In this example, we're asked to write the equation of the line that is perpendicular to the line containing these 2 points. So this is different because we're not given a line where we can find the slope by looking at the line. We have 2 different points that lie on the line, and so we need to use the formula for slope. And the formula for slope is y2 minus y1 over x2 minus x1. And that is a formula that you need to know. Using that formula and the points that we're given, I'll find the slope of this line to be -7 minus 3 over -2 minus 1. That's going to give us -10 over -3, and since both of those are negative, that's going to be a positive 10/3. If we want a perpendicular line, my new slope has to be the flipped fraction, the reciprocal, which is going to be 3 over 10, and since this one was positive, this one must be negative. I'm going to use that, and for our point, I can actually use either of these 2 points, and I always just go for the first one, but you can use the second one if you want to. And so we get y minus our y value equals our slope for our perpendicular line. Make sure you use the right slope and don't go back to this one. And then x minus our x value. And so this is our equation in point slope form, and from there we could put it in any form we chose. Okay, last example. Write the equation of a line that is perpendicular to the x-axis and passes through the point -5, 2. Well, it's important here, you need to know what perpendicular to the x-axis means. So if we think about this, this is our x-axis, this is our y-axis. If it's perpendicular to x, it's going to look like this. This is a vertical line, and vertical lines have a slope that is undefined, and there's a video on vertical and horizontal lines that you may need to watch to have this make more sense. But we know that vertical lines have undefined slopes, and so we have a special way to write these. These cross the x-axis, and so we write x equals the x value of the point that we have. And so this is it. This is the equation of the line that is perpendicular to the x-axis. Okay, well, I hope that helps, and I will see you in the next video.